Two strings are considered close if you can attain one from the other string using the following operations. Swap any two existing characters or transform every occurrence of one existing character into another existing character and do the same with the other character. Am I crazy or is this just comparing? How is this not comparing to the values of two letter counts? Because in these two examples, so this one has three B's and this one has three C's. It's got two A's and two B's. So I think that is it just compare letter, well, appearance counts? I think that's it. Okay, so we'll say word W1A for W1 appearances, for word 1 appearances. I could be totally wrong here. Letter appearances. So we'll say W1A, W2A equals now we'll just say for C in word 1 if C in W1A, then W1A C plus equals 1. Otherwise, it equals 1. Same thing for word 2. Okay, so now we just compare the two counts, right? Yeah. So now we'll just say return sorted W1A values equals sorted W2A values. That's crazy. No! Why is that false? Oh. Because that we just also had to say how do we say if set of word 1, can you do that, does not equal set of word 2, return false. That's gonna return a woo. All right, nice quick solution. So yeah, so there's two conditions here. So I thought it was just one condition because I thought that since you can just manipulate all the letters, all you care about is the number of appearances for every letter. You just compare the two appearances. But then that case came up. What if the letters were different? So, what if any letters were different? So to basically quickly check if um, I use set to get the unique values, and then I guess you can just that's cool. You can just say are they not equal? You don't even have to sort them. Um, Neat. That's kind of nuts, to be honest. In fact, I wonder if there's just not a test case for that, but that's cool. I'll take it.